everyone, and welcome to my YouTube channel. So in this video lesson, we are going to have another proof for the alternate segment theorem. We are now under case 2, subcase number 2. Still, we are going to have an angle and a chord, alright? The angle at the alternate segment and the chord separating the circle into two segments are not at the same semicircle. Alright, so without further ado, let's begin. Okay, so here's a beautiful blank space. Okay, so let's start with a circle. And then we're going to have a diameter, but in this subcase, we are just going to make use of the radius. So we are now going to connect A and B. That's another radius. Okay, and of course we're going to construct the very important chord. Okay, we are going to connect C and B. So that is the chord dividing the circle into two segments. The alternate segment and the segment with the angle formed with the chord and the tangent line. So we are going to form a tangent line of this circle with point of contact C. So C and then, so click on tangents and then C and then the circle. Okay, so again, let's do that. Tangents and then the point of contact and then the circle. So that's the tangent line. And now, we need the angle at the alternate segment. So let's have vertex D for it. So then we'll connect C at the end point of the chord and C, and then connect D with B as the end point of the chord. Okay, let's begin. So we have the tangent line CE here. And then we have the chord CB. So that's it formed an angle BCE. That's the start of this theorem. So let's measure angle BCE. Alright, so that's 45 degrees. Well, that varies, right? And since it varies, okay, then we can assign the variable x to this angle BCE. Okay, so let's do that. Okay, so we have variable x. And then, that's the lower part of a right angle. Can you see a right angle? Of course, yes, we have a right angle. Why? Because the radius is always perpendicular to the tangent line. So we can say then that angle ACE is equal to 90 degrees. Okay, so let me just change that, delete this, and then make another point here. Okay, and then measure up from ACE. Okay, so that's 90 degrees. Okay, so the lower part is x, that is the angle formed between the chord and the tangent line. So what is now the measure of ACB, the upper part of the right angle? So yeah, logically that would be 90 minus x, right? So let's write that down there. Okay, right, so let's measure up angle BCE first. Okay, so the measure of angle BCE is 52 degrees. So 90 minus 52, okay, do the math. Alright, so the upper part of the right angle is 38 degrees. Okay, and then let's add some colors. Let's continue with the story. So we have, in this construction, we have two radii. AC is a radius, and then AB is also a radius. Okay, and these two radii are sides of an of a triangle, right? With the chord CB, and then these two radii here, we have a triangle. And knowing that AC is a radius and then AB is also a radius, and they should be equal and congruent. So let's measure. So AC, radius AC is 4.1 and then radius AB is also 4.1. So the triangle formed between the two radii and the chord CB is an isosceles triangle. And you're correct. The base of an isosceles triangle, the bases are equal. So ABC will also be 90 minus x. Okay? Alright. And we all know that the sum of the interior angles of a triangle is equal to 180 degrees. So we're going to make use of that property of a triangle to find the measure or define the measure of CAB. And you are correct. It happens that CAB, happens to be a central angle. Okay, so let's call that angle CAB. So angle CAB plus 90 minus x plus 90 minus x is equal to 180 degrees. So we have that here. Okay, so 180 degrees or 180 is equal to angle CAB plus 290 minus x. Okay, this is the measure of the bases of the isosceles triangle. So we'll distribute. So 2 times 90 is 180, then 2 times x, negative x is negative 2x. And then let's swap the right and the left. Okay, using the symmetric property of equality. So we now have angle CAB positive 180, negative 2x is equal to 180. And then since we are finding the angle CAB, we transpose the other terms from the left to the right. So transposing positive 180, we have negative 180. Transposing negative 2x from left to right, we have positive 2x. And then copy positive 180. Okay, then copy angle CAB. And then as you can see, we have a negative 180 here, and we have a positive 180 here. So that can be cancelled out. So what remains at the right side is just 2x. Hence, using algebra, we have shown that angle CAB is 2x. Okay, double the angle formed of chord CB and the tangent line. So let's write that down. The central angle, the value of central angle is 2x. Now, what is the property, okay, between angle this now the relationship between angle CDB and angle CAB. Yes, CAB is a central angle, and then since angle CDB has a vertex D along the circle, then we call it an inscribed angle. So what's the relationship between the inscribed angle and the central angle? Okay, so we all know that the inscribed angle is always 1/2 the measure of the central angle that subtends the same arc. So what is 1/2 of 2x? It's x. Alright, so the measure then of the angle, okay, of at the alternate segment is equal to x. And what is x at the start of the story? That is the angle formed with the chord CB and the tangent line. Okay, so x is 52. So let's see if indeed the angle at the alternate segment is 52. So CDB, yes, it's 52. Okay, right, so we just have shown again that the angle formed at the alternate, or the angle formed with the chord CB and the tangent line will always be equal to the angle at the alternate segment. Okay, and let's appreciate another storytelling for this sub case. Okay, so thanks to Mr. Hall. All right, so again, it has an isosceles triangle in the proof, and the radius, the two radii are equal. So the bases of the isosceles triangle will also be equal. It happens that the one base, okay, of that isosceles triangle is the upper part of the right angle here. Okay, the right angle formed between the radius and the tangent line. Okay, so we represent the angle formed with CD and the tangent line as x. So the upper part, okay, or the base of the isosceles triangle will be 90 minus x. Look at here. So the angle formed between the chord and the tangent line is called DCH. So angle DCH, the green here, okay, or blue-green, it's equal to 90 because the radius and the tangent line, okay, are always perpendicular. So 90 minus x, the upper part of that right angle, okay, is equal to angle DCH, right? And then distribute the negative sign. So we have negative 90 and then positive x. And then 90 minus 90 is 0. And we now have x. So in other words, angle DCH is equal to x. And considering the isosceles triangle and the algebra behind the sum, okay, of the triangle is 180 degrees. Okay, using that property, we have derived that the measure of the central angle is 2x. Okay, and considering the property, the relationship between the inscribed angle and the central angle, where the inscribed angle is always 1/2 of the central angle, then we can say that the inscribed angle is equal to x, because 2x divided by 2 is x. Okay, so we have two algebra there. All right, so we just have shown again that the angle with the chord and chord CD and the tangent line is equal to the angle, always equal to the angle at the alternate segment. So I hope that you enjoy all of the storytelling today, and please continue to support my channel, and thanks again for watching. Bye for now.